System of linear equations and matrices, Chapter 4, Section 4.1, System of linear equations in two unknown. Introduction. In previous chapters, we studied single functions and equations. In this chapter, we seek solutions of two or more equations. It is proven that many real-world applications give rise to systems of linear equations, as we will see in this chapter. Computers are used to solve large systems of equations that are hard to solve by hand. Linear equation in two unknowns. A linear equation in two unknowns is an equation that can be written in the form ax plus b equal to c, with a, b, and c being real numbers. The number a is called the coefficient of x, and b is called the coefficient of y. A solution of an equation consists of a pair of numbers, a value of x and a value of y, that satisfy the equation. Example 1. Find all solutions xy of the following system of two equations. First equation, x plus y equal to 3. Second equation, x minus y equal to 1. We can graph these two equations, and when we graph them, we find where the two lines intersect. They intersect at point 2,1, and we call point 2,1 a solution of the equation, of the system of equations. Example 1 continue. To solve these two equations algebraically, we can use the method of elimination. We add equation 1 to equation 2 so that we are able to eliminate one variable. And then when we have one variable remaining, we can solve for that variable, and then we plug the value of that variable into one of the equations to find the second variable. Okay, now we put equation number 1, x plus y equal to 3, and then right beneath it we put another equation, the second one, x minus y equal to 1. We add the two equations together. Now you can see x correspond to x, y, and y. So when we add x to the x become 2x, y minus y becomes 0, and 3 plus 1 become 4. Now we have 2x equal to 4, then that means 1x is equal to 2. If 2x is equal to 4, then 1x would be equal to 2. We substitute for x equal to 2 in equation 1, and then we solve for y, and then we find y equal to 1. Therefore the solution is 2 and 1. For example number 2, solve the system 3x plus 5y equal to 5, 2x plus 7y equal to 1. Again, the solution to solve this system graphically, we first solve for y. So we solve the first equation for y. So y is equal to negative 3x plus divided by 5. And also for equation number 2, we solve for y, and then y is equal to negative 2x over 7 plus 1, 7. Then we graph them using graphing utility. And where the two lines intersect, this would be the solution. And we find that two lines intersect at point negative 5 over 11 and 3 over 11. So this would be the solution. Example 2 continue. First we solve the system of two equations graphically. Now let's solve these two equations algebraically. So algebraically we are using the method of elimination. We want to eliminate one variable from these two variables, and in order to do that, first of all, we want to make we want to make 3x6, and we want to make 2x6. How do we do that? We multiply the first equation by 2, and then we multiply the second equation by -3. So that means this 2 is going to be multiplied by 3x, it's going to be multiplied by 5y, and then it's going to be multiplied by 0 on the other side. Again, we use the same method, so we multiply we multiply -3 by 2, and then we multiply -3 by 7, and we multiply -3 by 1. So now we have 6x equal to 6x plus 10y equal to 0, and then we have -6x minus 21y equal to -3. And then by elimination we add equation number 3 to equation number 4, and then we find that y is equal to 3 over 11, and we find x is equal to -5 over 3. Okay, for example number 3, I have two equations. I want to solve them. I know we have two ways of solving this equation. It's either graphically or using algebra. So to solve the system of x minus 3y equal to 5 and -2x plus 6 equal to 8. So solving the equation for y before you graph them. So we solve equation number 1 for y, so I get y equal to x over 3 minus 5 over 3, and then y is equal to x over 3 plus 4 over 3. So when we graph them using a graphing utility, we find these two lines don't intersect, and this means there is no solution. These two lines are parallel. Example number 3 continued. To eliminate x, we multiply the first equation by 2. So then I have 2x minus 6y equal to 10. And equation number 2 from a previous slide is equal to -2x plus 6y equal to 8. So if we add these two equations up, we find 2x minus 2x equal to 0, -6y plus 6y equal to 0. So I have 0 is equal to 18. This is inconsistent system. There is no solution. Example 4, equilibrium price. The demand for refrigerators in West Pudong is given by Q equal to -P over 10 plus 100, where Q is the number of refrigerators the citizen will buy each year if the refrigerators are priced at $P each. The supply is Q equal to P over 20 plus 25, where now Q is the number of refrigerators the manufacturers will be willing to ship into town each year if they are priced at $P each. Find the equilibrium price and the number of refrigerators that will be sold at the price. Now, in order to solve this problem, we plot supply and demand equation. The solution of two equations is the point of the intersection, or we call that the equilibrium point. So the blue line is your demand equation, and your pink line, or you say yellow line, your yellow line would be the supply equation, and at the intersection this would be the point where the point of the equilibrium. The solution also, we can use algebra to solve this equation. At equilibrium point, we say the demand is equal to supply. So the demand equation is equal to supply equation, and we solve for P. So P become 500, Q is equal to 50. Example 5. Acme Baby Foods mixes 2 strengths of apple juice. 1 quart of beginner's juice is made from 30 fluid ounces of water and 2 fluid ounces of apple juice concentrate. 1 quart of advanced juice is made from 20 fluid ounces of water and 12 fluid ounces of concentrate. Every day Acme has available 30,000 fluid ounces of water and 3,600 fluid ounces of concentrate. If the company wants to use all the water and concentrates, how many quarts of each type of juice should it mix? So, solution of example 5. First, identify and table the unknowns. For the beginners, how much water do I need and how much concentrate do I need? For advanced, how much water do I need and how much concentrate do I need? In terms of ounces, I need 30 ounces of water for beginners and 12 and about 2 ounces of concentrate. And for advanced, I need 20 ounces of water and then about 12 ounces of concentrate to make an advanced juice. And the amount available, the amount of water available is about 30,000 ounces of water, and the amount of concentrate available is 3,600. So from the table now we are going to create something like equations, and now we have 30x plus 20y equal to 30,000, and also we have 2x plus 12y is equal to 3,600. Two equations, two unknowns, we can solve them using a method of elimination or any method you know. Now to use the method of elimination, I will have to multiply equation number 2 by -3. So now I have for equation 1 I will copy it again, so it's going to be 3x plus 2y equal to 3,000. And then for equation number 3 we're going to have -3x minus 18y equal to -5,400. And then when we add these both up, so x cancels out and we can solve for y become 150 and x is equal to 900. This is the solution.